Hi everyone. So first, what you have here is the image of an electroencephalogram. So in the last video, we talked a lot about what an electroencephalogram was, and we talked about how it recorded brain activity. Remember, we talked about slow wave sleep, which was basically long, kind of high amplitude, low frequency waves of sleep, which allowed you to recuperate and get more rest into your body, right? Whereas your awake state, in comparison to it, it was a lot more short bursts of activity with a much smaller amplitude and higher frequency. So here I have a picture of an EEG. This is of a person going to sleep. I took the fragments and I scrambled them around. And I want you guys to try and identify which states are awake and which state the person is asleep. I'm not asking you to identify the specific states. I'm just asking you to identify where a person is asleep and where a person is awake. Okay, so let's see if you guys got it right. If you guys guessed that in these two stages, the person is awake, and in this stage, the person is asleep, you would be incorrect. So, yes, you're right. The wake state is the first half here, but this end part here is the stage of sleep known as your REM sleep or your rapid eye movement period of sleep. Of so this stage of sleep here in the middle is your slow wave sleep. You can see how it has a high amplitude and a very low frequency in comparison to your REM sleeps. So let's talk about what REM sleep actually is. So as I talked about, REM sleep, REM, stands for rapid eye movement. Okay. So rapid eye movement talks about this hallmark sign of people in REM sleep, which is where their eyes rapidly go back and forth, back and forth. You guys have probably seen this when people are having nightmares and all of a sudden they wake up. You can see their eyes moving back and forth in movies, right? So rapid REM sleep is categorized by a very high activity state of sleep, which is really interesting because that's not what we associate sleep with, right? We associate sleep with rest. But REM sleep is known as a paradoxical state of sleep. Paradoxical state of sleep. Because as you can see here, both the wake and the REM state look pretty much identical, right? And so REM sleep is categorized with high brain activity, and it almost has bursts of activity as if you were awake, right? Bursts of activity similar to wake state. Another hallmark feature of REM sleep is a key topic that you need to know and a key vocabulary word that you need to know, known as atonia. So to break the word down, A usually means non, right? Or pausing or opposite, right? Tonia means movement. So putting those two words together, atonia quite literally translates to no movement, or in other words, you guessed it, paralysis, right? So REM sleep has a temporary state of paralysis. And the reason for that are actually kind of these neural networks located in your brainstem. So I have a picture here which shows you these brainstem kind of neural networks. So your LDT, PPT, and your SLD sub C. These are not words that you need to know, but what you do need to know is that these neural networks produce GABA, right? So if you guys remember from chapter one, GABA is your inhibitory neuron. Inhibitory neuron, which I'll switch to red because it stops or prevents firing. So in this case, it stops movement. And you can see here that the purpose of these neural networks is to produce GABA to inhibit spinal motor neurons, which are basically the neurons that communicate with the rest of your body to cause movement, right? This is from chapter 3. If you guys don't really know what I'm talking about, I suggest you go back and watch the videos that I posted on that. So what happens here is that the a certain part of your system will send it to your cortical motor neurons in your motor cortex, right? Motor cortex, and will tell them to stop firing. In addition, it will also tell your spinal motor neurons to stop, right? To stop firing as well. So essentially, what you're doing is you're canceling out any source of motor. So how I like to remember it is that you should have no motor, no chance for motor um, movement. So how you're going to do that is cancel out signals in your motor cortex and through your spinal nerves. So why does the body do this? What's the reason for this? Well, when your brain has these bursts of activity, the most common area for the burst of activity is actually in your motor cortex, right? And bursts of activity in your motor cortex, and similar to your wake state, can result in involuntary movements, right? Involuntary movements that cause hindrance to your sleep or that disturbs your sleep, right? Involuntary movements that disturb your sleep. So when you are constantly moving around in your sleep, or when other people are constantly moving, it's kind of interrupted for you to go to sleep, right? Your body can't fully immerse itself and heal itself if it's constantly moving or it's constantly putting energy into other places. So, what your brain does is, even though you have those bursts of energy as kind of a protective mechanism to make sure you don't hurt yourself and also to make sure that you're not disturbing your sleep, it paralyzes you temporarily. The very interesting part that we're going to talk about in the next video is that the timing of when these are activated and deactivated are controlled by a structure known as your hypothalamus. So your hypothalamus is located right underneath your thalamus in this purple area over here. And what you guys should kind of know is that it controls homeostasis. Homeostasis, which is the balanced state of your body, the state of your body which your body thrives in, right? And in this hypothalamus, you have something known as your suprachiasmatic nucleus. Suprachiasmatic nucleus, which is often just abbreviated as SCN. And that is located, I think, a group of neurons in the hypothalamus. The signals that are sent from this area in your brain control these neural circuits, which is why you're not paralyzed when you wake up, but you're paralyzed when you're in REM sleep. So the last thing that I wanted to go over are the state or the way that these slow wave sleep and your REM sleep alternate, because you're not constantly in one state of sleep and then it switches over and then you suddenly transition into another state. It's not like that. You have different segments of sleep, right? So you have different sessions, you can think of it as. So in one block of your sleep, which usually lasts somewhere from, I believe it is 90 minutes around, give or take. And in that, as you guessed, since the purpose of sleep is mostly to recover, most of it is slow wave sleep. So slow wave sleep. which lasts from anywhere from 75 to 80 minutes, right? This last portion here, the end portion here, this piece is your REM sleep. REM sleep, which will last anywhere from 10 to 15 minutes. And obviously, this isn't just one sleep, right? Humans sleep for around 8 hours every day, or you should be. And because of that, the healthy person will tend to have around 7 to 8 of these cycles. 7 to 8 of these cycles. Okay? So that was a bad line, but there we go. So what you need to understand about REM and slow wave sleep is that they work in blocks, right? They work in blocks of time and they alternate. And the reason for this is that actually, as morning approaches or as you start to wake up, your REM sleep tends to increase in duration, right? So as morning approaches, as morning approaches, your REM sleep tends to increase, which is really important because your brain essentially, that's your brain's way of starting to wake up and get accustomed into that rapid thinking that you use in your wake state, right? So you see how here the wake state is very similar to your REM sleep. The reason why you have more REM sleep as you tend to wake up is because that's your brain's way of preparing you to start thinking again for the day. Thank you so much for listening to this video on REM sleep. These are the big kind of concepts that you need to know for brain B and really a lot about what you need to know about your brain as well. In the next video, I'm going to be going over a lot more detail into the slow waves versus REM sleep cycle and how that's regulated by different neurotransmitters. And yeah, thank you so much for listening, everyone. Have a good evening.